Hello, welcome back. We continue our discussion on work power energy. I think till the previous lecture, we were looking at the gravity related and sometimes the friction related cases for chains, ropes, etc. How to find out the velocity of the chain by using the work energy theorem. And where work energy theorem cannot be applied, that also we saw. Now, I think I did make a reference of spring also before. Now let us go to springs, right? Spring, of course, I told you, one is a light spring, the other is a heavy spring. Now, as far as the light spring is concerned, I think we already discussed this is the mass of the body. Therefore, you are able to work on, suppose if it is pulled by E, the potential energy stored is this, half k square. That's how we have seen that, okay? Now, coming to this heavy spring, there is a problem. For example, let us say this is mass M. Mass of the spring itself is ms. So suppose at one stage, if it has a velocity, the entire spring cannot have the same velocity. The velocity at the edge or here is 0. If I take the length of the spring to be L, at any distance x, I consider small elemental mass or length dx having a mass dm, right? And what will be Vx? If I presume linear variation of velocity, then V minus 0 by L, that is the rate at which velocity varies from this point, into x will give you Vx. It's a linear variation I have taken. In fact, you know how you get that. dv by dx, let us say that is a constant, or dv is equal to k dx. An integral dv, you start from, say 0 to v, and this is 0 to L. 0 to L. So what do you get? V is equal to KL. Okay? But the same thing if I take from 0 to Vx, then this will be 0 to x. Then what do you write there? Vx is equal to Kx. Now you divide these two equations. You divide the two equations by V by KL. You see, KK gets cancelled. Therefore, Vx is equal to V into x by L. Now remember, if it is not linear, generally it is presumed to be linear. They may give some function that you can work out based on that. Okay? So this is how I got it. Now, what is the kinetic energy of this elemental mass? Half dm Vx square. This is the kinetic energy of this part that you are considering. Because it is 0 here, it is a half mv. Now I am talking of only the spring, not that of the body yet. Okay? So if you want, what is this lambda dx, as I was telling you? I take it to be a linear density here, which is of course constant. And what is Vx? V into x by L, because there is a square, I have squared it. So now the next step is integral dk is half lambda v square by L square integral x square dx. Now 0 to k, 0 to L, you have half lambda v square by L square x cube by 3. If I substitute 0 to L, you will get L cube by 3, but L square gets cancelled. Half lambda L is mass of the spring, ms by 3 v square. This is the kinetic energy of the spring. If you want of the system, K of system is half v square into m plus. Mind you, this is only if there is a linear variation. Generally we accept linear variation. Otherwise they may say it goes on increasing with x, dv by dx itself increases with x. So then I will take dv by dx is equal to some constant into x. Then I will work out how do I get it. I'll just show it to you. Now this is a very important thing for you. In case heavy springs are given, what is the heavy spring kinetic energy of a heavy spring is half ms by 3 v square. That v is the velocity of the edge of the spring. Now supposing this is linear variation of v. Suppose if I take dv by dx is some constant, don't get carried away with k here, let me take it as some a here, so that I will write ax dx. Now the same thing, 0 to v, 0 to L. So you have v is equal to Al squared by 2. If I substitute 0 to Vx, now you get here A into x squared by 2. Now you divide so that you get Vx is equal to v into x squared by L square. This is possible. We do not know. In case of that, I think then what will happen? If we so half dm lambda dx vx square, v square into x raised to 4 by L raised to 4. This is kinetic energy of the spring. I am now taking half lambda v square by L raised to 4, x raised to 5 by 5, 0 to L. Half lambda v square L raised to 5 by 5. And this is L raised to 4. This gets cancelled. Half lambda L is mass of the spring into v square. So this is half ms by 5 into v square. In fact, this is dv by dx is proportional to x. Likewise, non-linear variation. Don't take any of these things as standard. Generally, this is accepted, but it can be anything depending on the elastic properties of the spring. Okay? So be careful whenever they say heavy spring, you have to add these factors. That's very, very crucial. Okay? Now, the spring, if you see, I would take a, I think I did explain, I think a combination of spring and gravity. I'm not very sure of that, but anyway, I'll do that here. Uh, Suppose this is the natural length of the spring. This is theta. If you release this, what is the elongation here? E. How do you get E here? This is nothing but EL plus E. Okay? How do you write that? Cos theta is L by L plus E. Secant theta or sec theta is L plus E by L, or 1 plus E by L, or E by L is equal to secant theta minus 1, or L into C. See, somehow or other, based on the geometry, trigonometry, try to get the elongation part. And this is natural length, this part. So what is the energy stored here? Half K E square. By the time it comes here, it is having a natural length where the potential energy stored in the spring is 0, and there is no change in the gravitational potential energy. Therefore, all this should result in, this is a light spring. So you get V is equal to K by M and root into E. E is L into, likewise, you get it. You get the point? This is natural length and this is already in an elongated state. So this is very important. Okay, fine. Now, if the same thing is tilted in the horizontal, this is natural length. This is theta. Okay, L theta. Now this is taken here and released. By the time it passes through, what is the velocity? Suppose if they ask, what are all the things involved, you have to see. One, you can see the work done or the potential energy, whichever way you want. Suppose the GP is 0 here. Then what is the GP? This is L, this is tan theta is equal to Y by L, or Y is equal to L tan theta. And this is cos theta is L by this is equal to L secant theta. Okay? Now, as before, what is the, if I take this as the 0 level of potential energy, I have spring potential energy there. Spring potential energy is half K E square. Gravitational potential energy is mg into h, that is L tan theta. Now, by the time it comes here, GP is 0, spring potential energy is 0. So the total is converted to kinetic energy. So you can find out E as before. E is equal to, this is L plus E is L secant theta or E is equal to L to secant theta minus 1, substitute and get the answers. Is this clear to you? Right. Okay. Now, then this is of course one way of looking. I'm still looking at gravity, that I'm not involving any friction at any stage. And spring, we have seen a couple of cases. Now let us see like this. This is K. Suppose you allow this system. Well, I am involving only spring and gravitational potentiality. It is a smooth surface. Okay? It is a smooth surface. No complications anywhere. Likewise. Like pulley, like spring, everything is fine. Now, by the time, see, as this falls, let me tell you, as this falls, this will move here. Something like that. Okay. What will happen? This is the spin force. Okay. This is a normal reaction. This is M1G. On this side you have, this is theta, this is theta, you have K cos theta. Now it is initially N1, N is equal to M1G. Now once it comes here, N plus K cos theta is equal to M1G. It keeps on moving. At one stage, that N may be 0, means the body could be lifted up because the upward component of the spring force is trying to pull up the body. Therefore, there is a chance at that instant the velocity, you may find out what is this, they may ask any of those things. We will see how to work on those problems. In which case, cos theta is equal to M1G by KE. Okay, but what is E? See, the natural length is L. First of all, let me see. And what is cos theta? This is L secant theta, I told you, isn't it? So L secant theta is equal to L plus E. So E is equal to L into E secant theta minus 1. If I substitute K, E, what is E? L sec theta minus 1 into cos theta is M1G. If I expand the secant theta cos theta, that becomes 1 KL into 1 minus cos theta is equal to M1G. I can find out by KL cos theta is, so Fine. You are getting some expression for theta here. Now let us say this is, what did I do now? I used Newton's second law to get a scenario where the body is likely to lose contact. At that instant, the velocity here is v, the velocity here also is v. Okay? Now, how far has this descended? So, this is the thing. If this is L, this is theta, this is L tan theta. So, this has fallen by L tan theta. You get my point? So, I am writing here E is equal to, okay? Now, what do I do? What is the potential? Initially, of course, potential energy is zero. Now, the spring, there is a storage of potential. Though the spring potential energy has increased, gravitational potential energy has decreased. It has fallen. How much has it decreased? M2 GL tan theta. How do you write that? Decrease in GPE, increase in spring potential energy of Ke square. Okay? So, total, what is the fall in the potential energy? See, if there is no fall, you won't have this kinetic energy coming into play. So, fall means the decrease is this and this is increase. Okay? So, fall I have taken. What is the fall in potential energy? And part of it has gone to the spring potential energy and the remaining has gone to the kinetic energy. What is kinetic energy here? This body has V, this body also has V. Therefore, half m1 plus m2 into V square. It is clear? Right. Now, once you have cos theta here, and tan theta can be obtained, got the point? Now, so I write here your cos theta is 1 minus m1g by kl, and of course E you can write in terms of L, sec theta minus 1, you can write it as E is equal to L into 1 by cos theta minus 1. L into 1 minus cos theta by cos theta. So how do you write cos theta? I can write it as KL minus m1g by kl. In fact, that way also I can write, why all this? L into 1 by cos theta, kl by kl minus m1g. So if I take kl gets cancelled, minus minus plus m1gl by, right? This is your E. So E I can substitute right away. And once you have cos theta, you can substitute to tan theta. And if L is given, M1 is given, M2 given, you can find out E. See, in a problem, they will specify. These are all given, so I can work out the problem, but that is confined to them. Now I'm generalizing the problem. I do not know what are the variables you see? Theta, L, M1, M2, K. isn't it? Theta, L, M1, M2, the 5 variables. You got the point? And now you have two equations. This is one, either two equations. That means they have to give you 3 variables so that you can find out 2 variables from this. That is important here. This is what I call as concept building. Once you know this, you come to this extent, then you know how to solve this problem to get whatever parameter is asked for. It is clear to you? Right. You need to work out these models on your own. That is very important. So, next what we will do, we will look at friction spring combination. This is light spring, no mass. And frictional coefficient is mu. There is all rough surface. I have pulled it by E naught. I have pulled it by E naught and released. This is the thing. So, what will happen? Let us see. This body will come down, come. And by the time it comes here, it will have certain velocity. By virtue of inertia, it will start getting compressed, but frictional force opposes there also. At some point, it will stop. And then come back again because the spring pushes it. So how it goes, I'll just give you a sketch. So likewise, and finally it comes to a stop. This is the thing. Is that clear to you? What is the energy available for the total system now? It is horizontal, so gravity doesn't come into picture. If it is inclined, gravity will automatically come. Be careful. Okay. Now coming to this. What is the total energy of the system available? Half k into E naught square. This is the energy of the system. Now, if I want to know what is maximum compression, in first case, I want to know maximum compression. Let me call this maximum compression as C naught. Okay? What is the energy now at this stage? Half k C naught square. Why? Whether it is compression or elongation, storage is there. Storage formula is there, not storage is there. So you have this. So, suppose 100 units of energy. Now it has only 80 at this. Maximum compression means the velocity is 0 here, the velocity is 0 there. Okay? Fine. What is the energy that is spent? Half k square minus half k C naught square. Initially 100, it's a 20. What happened to this 20? Nothing is converted to kinetic energy because kinetic energy change is 0. No change in kinetic energy. But what happened to all this? It is used to do work against friction. What is the frictional force? Kinetic frictional force mu m. That is mu mg. Now it is constant you took. Therefore, Fk times C naught plus E naught. That is the total length that it has traveled. That means what? 100 units it is doing work against friction. Kinetic energy is changing. Finally, kinetic energy changes become zero. Therefore, in fact, I can say the work done by spring force and the work done by frictional force total is equal to change in kinetic energy. Either way you can, I'll show you that. I am now looking at, see, you can always look at these two possibilities. Work done by spring, work done by friction, change in kinetic energy. I'll show you. The other one, what is the source of energy for this whole system? Potential energy. What? Of the spring. No other thing available there. Therefore, if it comes back and then goes to the compressed state, now change initially K0, finally K0. So the change in potential energy is the actual amount of work done against friction. So against friction is mu mg into C naught plus E naught. Now half K E naught plus C naught E naught minus C naught. This gets cancelled. So E naught minus C naught is equal to 2 mu mg by K. You want to know C naught is E naught minus. This is the maximum compression in the spring, this one. Suppose you know what, it won't stop there, it will go and then it will come somewhere here. I take it as E1. What is the next highest elongation of the spring? I can write E1 is equal to, by the analogy I am writing. If it is E0, you got C0 as this. If from C0, you go to E1, therefore C0 minus 2 mu mg by K. I told you, so when it is E0, my C0 is compression. If it is C0, what is E1? Get the point? So, I hope it's clear. If it is not clear, I will explain. I will explain it. Now, this is the original thing. This is E0. So, this is your C0. Mechanism is same. Spring potential energy, work against friction, compression. Now if it goes from here, it will go to some point like this. So E0 to C0 or C0 to E1 are qualitatively one and the same. You get my point? So if I want to know C0, you got like this. Like this. If you want to know E1, instead of E0, substitute C0. So I got it. You get the point? Okay. Now, E1 is equal to C0 means E0 minus 2 mu mg by K. This is the. That means it has completed one cycle. In one cycle, it has come to this point. Okay? Fine. You can go on writing this. You can find out C1, you can find out E2, you can find out C2. There is no end to it. How long does this continue? Till the body stops. Where does the body stop? The body stops when frictional force is equal to spring force. Spring force Kx is equal to mu mg. That x can be E, that x can be C, it makes no difference to us. Till this point, it keeps on moving. Okay? Fine. If that is the case, When will it stop? When x is equal to mu mg by k. In such a scenario, I may ask, what is the total distance traveled by the body? Now that is the second question. Total distance traveled. How do you get it? What is the initial potential energy, final potential energy of the spring? Everything is spent doing work against friction. Work against friction, frictional force magnitude is constant. Okay? See, E naught plus C naught plus C naught plus E1 plus. The total thing is your distance. So, Fk into d, because frictional force is invariant there. Kinetic frictional force. I hope you have understood this. If I want to work out till, I will say E naught plus C naught plus C naught plus E1. That is the total distance traveled. And if this is the total distance, what is distance? This plus this plus this. That's it. Fk is common in all the things when you look at the work done. Fk into E naught plus C naught plus Fk into C naught plus E1. What is common? Fk is E naught plus 2C naught plus E1. What is this? Nothing but the distance. Let it make any number of trips. The distance is d and Fk is mu mg. X is mu mg by k, half k E naught square minus half k is equal to all this. And you can find out the distance by dividing this. That's all you have to do. You can simplify this and write the way you like it. Maybe 2 mg k E naught square minus mu square m square g square by k. This is the total distance traveled. Is this clear to you? This is very important. Model, how to do work against friction, etc. Now suppose you want to know what is the work done by spring. What is the work done by spring? E naught to 0, it is the spring force and movement is in the same direction, so positive work. Work done by spring is half k E naught square, but during the process of compression it is negative. This is work done by spring. Work done by friction, Fk mu mg into E naught plus A naught. Work done by friction, a minus Fk into all this. Sum of these two is equal to change in kinetic energy, which is 0. So how do you write that? Now you take it on to the other side, the same problem as I have done before. The final expressions will not differ. But how do you want to proceed is up to you. Use work energy theorem, or logically I can think that yes, this is the energy available. How much I can get that converted into the other forms, then I would equate it, get those answers. I hope this is clear to you now. Okay? Fine. Now, you have seen spring friction, but no gravity. Suppose this is rough. I am now dropping a body here. What will happen to this? It will come, hit, and the whole thing is compressed. Agree? I will call it as C naught. What will happen then? The spring will push it up. It will push it up, and here the spring and the body lose contact. So it will come up and stop somewhere there. You get the point? It is released, it will hit, and the whole thing gets compressed. Then, so let me say this has gone to X naught and stop. Again, of course, it will come back. Now, we will start the scenario. I don't want to give a problem to you. We will look at the scenario. By the time it comes here, that is the maximum compression in the spring. What is the source of energy for this? The source of energy is gravitational potential energy. Okay? Now, if this distance is L, I don't know if it is L, how far has it traveled? How far has it traveled? L plus C naught. So, this point is, this is beta, this is L plus C naught sine beta. Okay, this is that. So, M G L plus C naught sine beta. This is the gravitational. What has happened to all this energy? Partly here velocity 0, so no kinetic energy. It is stored in this, and the rest is used to do work against friction. Against means positive. By friction in this case is a negative. So I have plus Fk into L plus C naught. I have established one equation here. What is Fk mu n? What is n? Mg cos beta. So I have one equation here. Fine. There's no problem with this. Now look at this. If I take this, what is this distance? L minus x naught. Okay? Now the whole thing has gone here and come till this point. What is the total work done against friction? Total work done against friction. Mu mg cos beta mu n into the distance L plus C naught plus C naught plus x. Be careful. This is 1, 2, 3, 4. 1, 2, 3, 4. Distance, total distance. L 1, C naught 2, C naught 3, x 4. Total. Now, if it comes here, what is the falling potential energy source? What is the potential energy there? Mg L minus x naught, L minus x naught sine beta. And these two are the same. Mg L minus x naught sine beta is mu ng cos theta into everything is given. Now again, C naught, X naught, L, M, beta, that's it. 5 variables, 2 equations. So they'll give you 3 variables. Let them give anything you can find out. You understood the point here? That is how you have to work on the model. Here I have got involved both the things. Okay? Fine. Is this clear? Now what I do, because the previous example was involving, okay, I think it is now time up. Maybe I'll continue in my next lecture. Thank you.